This is your 6.2 notes. Not too much to this section. It's just another section where we do modeling and we use the regression feature in our calculator. So here's a data set, and I'm going to take this data set, and it tells us to find a cubic function that models the data in the table with x equal to the number of years after 2000 and y equal to the number of millions of people. So this is going to be 0, 2, 3, 4, just like it has been several times before, where we adjust x to be years after some certain year. Alright, so I've got my data in my calculator, and now I'm going to find the cubic function that models the data. Okay, so for cubic function, when I press the stat button and I go over to calc, remember that's where our regression menus are. So here's where the regressions start. I'm going to go to cubic. Okay, so remember there's a line, degree 1, degree 2, quadratic, degree 3, cubic, degree 4, quartic. So they want us to give them a cubic function. So I'm going to go to cubic regression. Alright, and like previous times, I'm going to hit vars, scroll over to yvars, function, y1, okay, and then hit enter. Alright, there's our regression function. If you ever ask, about how good of a fit it is, you can come in here to catalog, go to D. Alright, you're in alpha mode right now, so go to D. Alright, and then scroll down until you see diagnostic on. There it is. Turn it on. Now hit second enter a couple times, repeat that cubic regression y1. Alright, now after you're done, it'll give you your r squared value. Okay, so if it doesn't show up, r squared, again, that's the what we call the coefficient of determination. That tells us how good of a fit this thing is. The closer that number is to 1, the better your model is. Okay, so anyway, find a cubic function that models the data. Again, let me paste this in there. It just makes copying it down a little bit easier. So our cubic is y equals, alright, y equals a is 0.064 x cubed. Alright, that's why it's a cubic. Plus b is negative, I'm going to change that to minus 0.828 to 3 decimal places like I did the first one. 828x squared. Okay, c is a plus 3.638 x, and then d is a plus 30.864. Alright, so there's our model that gives us the number of millions of people in poverty level, and then x is years after 2000. Okay. Alright, we want to graph the function and the data on the same axis to see how well it fits. Now that's why we did that y1 thing up there. Alright, remember when we did that y1 right there, that stored this entire model we came up with into our calculator. Okay, now before you hit graph, hit second y equals, go to your stat plot and turn your plot 1 on. That way you have your scatter plot stored in there. And now press zoom 9, which is the zoom stat menu. Okay, and there's our data and our model to go along with it. Now again, I'm going to plot that in there to answer part B. Alright, so there it is in there. Again, you see our data points, and the model is the solid line, and it goes in there and fits the data very well. Alright, and then part C says use the model in part A to estimate the number of people below the poverty level in 2008. Okay, now a couple things we can do here. I'm going to extend this page first of all. First thing being, since we've got it graphed and it's just sitting there from the last thing that we did. If we hit trace, again, when you hit trace the first time, when you have your step, if you just look at the y equals menu, plot 1 is there first, and then your graph is there next. So anytime that you're in the graph, if you hit trace, it goes to the top. So it's going to go to the plot first. So when I hit trace, I'm in the plot, I'm in the stat plot. I had to hit down to go to the model. And once I hit down to estimate what happened in 2008, remembering that X is years after 2000, I hit 8 and hit enter. Right, and then there's our estimate. Right, so 39.86 million people. Alright, now the other way that I could do it, again, because I have it stored in Y1, I could hit second mode to get out of the graph menu, hit clear, and then go to vars, Y vars, just like I did when I'm storing it in there. But this time when I highlight it, there's no cubic regression in front of it, and I hit parentheses, tell it the year I want, 8, which corresponds to 2008, hit enter, and again I get that same number. Okay, so you can do it from the graph mode using the trace feature, or you can get out of the graph mode, come back to your home screen, and use the vars menu to get there. Again, it's vars, y vars, enter, enter, and then type in the number. Make sure you put it in the parentheses. Okay, if you forget the parentheses, right, it multiplies and it just doesn't work properly. Okay, so make sure you put the parentheses in there so you get an accurate predictor. Okay, so that's the two ways that you can do part C. Alright, here's another data set, and again it's giving us data on unemployment. We want to make a scatter plot again with 0 equal to 2000, and what is y is the unemployment rate. So this is similar to an example we saw in the last homework set, or in the last chapter. Alright, so once again I have my data in here, and I'm going to press stat. This again, it wants me to make a scatter plot of the data, so I'm going to hit second y equals the stat plot. Alright, I've got it turned on, so I'm going to hit zoom 9. Alright, now what's the question? It asks me to make a scatter plot of the data to determine if the data can be modeled by a Quartic function. Remember, Quartic is degree 4, and degree 4 functions have a maximum of 3 bins, so 1, 2, 3. So a Quartic does look like it would work well here. So I would just say yes, a Quartic should work well because there's 3 bins. Okay, and then it wants us to find the Quartic function. Well, we've already got all the data in there, obviously, because we made a scatter plot. So just go to Stat, scroll over to Calc, come down to Quartic Regression, Quart REG, enter again vars, y vars, function y1, enter. Alright, I'm going to put this in there, and again it says down because it's got r squared on there. Alright, 0.76 is not a perfect fit. Okay, like the last one was 0.97 with the cubic that we did, but it's still going to be fairly good. Alright, I'm going to copy this so I can put it in there better. Alright, so there it is, and I kind of ran out of room there, but I'm rounding these to 3 decimal places. Again, a, b, c, d are all coefficients in front of x to the 4th, x cubed, dot, 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 means the pattern continues, so c is for on x squared, d is on the x term. Okay, and then all the way down to this e being the constant term. Okay, and then graph the unrounded model in a scatter plot on the same axis. Now what that means, unrounded model, alright, I just rounded it. Right, I rounded all these to 3 decimal places. It wants me to use all these decimal places when I make my model. So again, that's wanting you to use that vars feature, okay? When you do your regression, when you come over here, it's wanting you to put in the vars, the y-vars function y1. That way, again, when you go to your y1, it has many more decimal places than what I wrote down as my answer to part B. Okay, so zoom 9 again for zoom statistics, and then we'll put this Quartic function in there. Right now, as you see, again, it was only R² was only 0.7 something here, so we're missing a lot more points than maybe we're used to seeing with a lot of our other regression models. Right, it's just it can't handle that really steep bend and this leveling out here. So a Quartic, you know, it did fairly well though. I mean, it still gets the overall trend. Right, low values here, peaks, comes back down, and then it goes up again and picks up some high values. So this, I mean, it does that, but it just doesn't hit all the points exactly. So that's why we're not seeing a higher R². Alright, so I'm going to put this in there with it. Alright, so I've got it in there with part C. And then part D, use that unrounded model to estimate the unemployment rate in 2016. So again, one of 2 ways. I can hit trace. Alright, I'm in the plots again, so I want to make sure I come down to the model, and then we want 2016. So if I type in 16, hit enter, y equals 2.00, so y equals about 2. So about 2.00% unemployment. In 2016. Alright, I'll hold my breath. Now again, the other way, second mode, get out of the graphing mode. Clear out your screen if you want to. Come to vars, y-vars, function y1, just like you were going to store it, and then tell it the year. So 2016 would be 16. Alright, hit enter again, we get that 2.00. Alright, so either one of those 2 ways will work just fine. Alright, now last part in this, third and fourth differences. So what this is talking about is for lines, your first differences for outputs are constant. Alright, if you have quadratics, the second differences in your data are constants. Alright, and then for cubics and quartics, it's going to be your third and fourth differences. Okay, so whatever the degree is that models it well, it's that difference is what should be constant or relatively close to being constant for that type of a function, that degree polynomial to model your data well. So just to give you an example, here's your x's and here's 2 different data sets with y's. So this is y for the first data set. This is y for a second data set. Okay, but they're xy pairs. So 1, 3, 2, 14, 3, 17, so on and so on. So the first thing you want to look for is even spacing in your x's. And we have even spacing in our x's. So that means we can look at first differences, second differences, third and fourth to see if we have some type of a polynomial model that'll work well there. So we're going to look at this one first. Okay, so there's the 3, the 14, the 47, the 114. Alright, and what we're doing here is we're subtracting. So 14 minus 3 is 11. 47 minus 14 is 33. So on and so on and so on. We're just subtracting the bigger number minus the smaller number. Okay, this is the row of our first differences. And the first differences are not constant. Okay, when the first differences aren't constant, that means a line's not going to do a very good job. Alright, now we're taking the second differences. So meaning we take those first differences, that first difference row, and we subtract those. So 33 minus 11 is 22. 67 minus 33 is 34. 113 minus 67 is 46. Alright, and we're getting our second differences. Now if these were equal, constant all the way across, then a quadratic would do a good job. But again, these aren't equal. They're changing. So a quadratic doesn't do a good job. But if we look at our third differences, 34 minus 22 is 12, 46 minus 34 is 12, and 58 minus 46 is 12. Our third differences are all equal. Alright, so that means a cubic is going to do a perfect job on this data set. Alright, I've got these data sets. There's the x's, the y1, y2 stored in my calculator. I'm going to hit stat. I'm going to come over to calc and I'm going to do cubic regression. Right, that's the third differences are equal. I'm going to do cubic regression on list 1 as the x's, comma, list 2 as the y. Since I have more than 2 lists in there, I'm telling it which list I'm doing this on. And hit enter. Alright, notice here r squared is equal to 1. Okay, that means that this is a cubic hits it perfectly. Alright, if I did comma vars y vars function y1, ran it that way and then hit, make sure my stat plot is on, and hit zoom 9, we would see that this thing hits this right through the heart of every single point every time. Okay, so it's perfect, a perfect model. Now going further, again this time we're using this for the second one, and we're going all the way down to the fourth differences. Okay, so there's the outputs, there's the y's. Alright, notice their first differences aren't anywhere close to being alike, nor are the second differences, and this time the third differences aren't even alike. But if we look at the fourth differences, we get the same thing. So this time the fourth differences are identical. Okay, so that means a quartic regression will work well. Alright, so this time I'm going to do the same thing I did before. I'm going to go to stat, go over to calc. This time come down to quartic regression. This time though, my x's are in list 1, comma, my y's this time though are in list 3, so I have to hit second L3, and I'm also going to put it in vars y vars y1. Okay, hit enter. Alright, we see this. Alright, A is 1, B is -3. This notation, this 5.2 E -11, remember that's scientific notation. Alright, and E -11, E -10, if some big, 2-digit number here, the number of places you move that decimal to the left, this is like virtually saying 0. So just know that that just means it's virtually not there. Okay, now if I want to graph this one, make sure when you go to your stat plot this time, remember it says L1, L2. So go in there and tell it it's not L2 anymore, it's L3. Okay, and then hit zoom 9 so we can look at the data. So there's our points. Here comes our quartic, and again it goes right through the middle of all the points there, so it hits it perfectly because the fourth differences are constant. Alright, so that's what we're talking about, third and fourth differences. So if you see some homework problems and they talk about third and fourth differences, this is what you're being asked to do. Go through there, come up with, take the list of the y values and subtract them one from each other, make a little table like this to come up with your second, third, fourth differences, however many you're asked to find.